Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over a couple problems involving internal energy, heat, and work. And so the two problems I'm going to be dealing with are problems where the system is either absorbing or giving off some energy as well as doing work on the surroundings. And a lot of times, a lot of these problems, the system that we're working with in chemistry is a chemical reaction of some sort. So let's look at problem number one. Now, problem number one involves a potato gun. So for those of you who have never done a potato gun, they're really easy to make. I've done a potato gun with my class before, where we went out and we got PVC pipe, and in class we made our potato guns. So it's you can find instructions on the internet pretty easily. Basically, the way it works, or at least the ones that we made, was an aerosol-based one with you had a chamber that you filled with aerosol, and then you had some sort of ignition switch that would create an electrical spark, which would then light the aerosol, and that would cause the explosion that would then propel the potato out of the gun, right? So in this case, when we're talking about the potato gun, we're talking about the fuel being burned. The fuel is the system. So that's the reaction. You have a combustion reaction, and then heat is given off, and work is produced. So in here, we have with the potato gun, we have in this case, we're told that 855 joules of work is being done. So the expansion of the gas, or the system, the reaction is then going to do work on the surroundings, which is, part of it is the potato. So the potato is going to be pushed out of the gun, and so that's the work. That's the work being done. So we're told that you have 855 joules of work being done by the system, the reaction. And then we're told that 1422 joules of heat is also evolved. And so then they're asking us, what's the internal energy change of the system? So you got to think about it from the point of view of the system. So it says that 1422 joules of heat is evolved from the reaction. So if it's evolved, it's coming from the reaction. So that means that the system is losing that heat. So that's going to be a negative number. So if we start with the equation, the Q, the heat, is going to be equal to, delta E, which is the internal energy, is going to be equal to Q, the heat, plus the amount of work, right? And now, so we have to figure out what are the signs of these, a negative and positive. So again, with the heat is being given off. So that means that heat is being lost by the system. So if anytime you lose energy, that's going to be negative from the perspective of the system if the system is losing energy. So that's going to be a negative. So that's going to be equal to a negative 855 joules. And then what about the work? So work, you have to think of it in the same way. So if the system is doing work on the surroundings, then you could think of work. You could think of work as energy, which it is in this case. When you're doing work on something, then you're losing energy, right? So I'm putting energy into something else. So if work is being done by the system onto the surroundings, then that energy is being transferred from the system to the surroundings. So it's losing that energy. So work is going to be negative in this case. So the system is doing work on the surroundings. So 855 joules is going to be negative. Oops, I forgot. I switched these around. So this should be 1422 for heat. And then this is going to be negative for the work, 855 joules. So then when you add those together, you get, what did my answer tell me? You get 2,277 joules negative, that's negative, joules of energy change. So the system lost a total of 2,275 or 77 joules of energy. So that's the first problem. The second problem is where you have a piston and a cylinder assembly. So in this case, you can think of like this being a piston and cylinder in your combustion engine of your automobile. The gas is being combusted, or the gas is being heated up. It expands and pushes the cylinder or the piston of the cylinder out, creating more volume, right? So work is being done on the piston, right? So again, the system that we're looking at is the expansion of the gas, the heating of the gas in the cylinder, and then that gas, or that reaction that occurs that expands the gas, is going to push the piston. So now again, work is being done. So here we're looking at the system. We're not looking at a reaction. We're going to actually be looking at the gas inside of a piston. So we're heating up the gas. So you have a piston and cylinder. The gas is on the inside of the cylinder. You heat up, you put heat into the cylinder, heat into the gas, and so the gas is going to absorb that heat. And then absorbing that heat, going back to our gas laws, the gas is going to expand, right? Because the particles are going to be moving faster, they're going to hit the sides of the container harder, and so the piston is going to move and expand the volume. And then by moving the piston, the gas is doing work on the piston, so it's moving the piston. But energy is being absorbed by the gas because we're heating up the gas. So in this case, energy is being absorbed, heat is being absorbed in this problem. So if we go back to our equation again, delta E, the change in internal energy, is equal to the heat plus the work. In this case, heat is absorbed, so heat is being gained by the system, energy is being gained by the system, so this is going to be a positive. So that's going to be equal positive 559 joules. And again, work here is being done by the system on the surroundings. So it's doing work on the surroundings, so work is leaving the system. So energy is leaving the system because the system is doing work on the surroundings, right? So if you're doing work, then you're losing energy and you're putting energy into whatever you're working on. So that's going to be negative again. So that's going to be 488 joules. And so that together is going to be, that's going to be 12 plus 59, it's going to be 71. So that's going to be 71 joules positive. And so that is the change in the internal energy of the system. So in this case, it was positive, just slightly positive, and this one is very negative. I hope this was helpful. If you like this video, go ahead and like it. Hit the notification bell for more, be notified for more videos. Subscribe to the channel. Make a comment in the comment section. Let me know what you think. If you want to know anything else or have me do a video on anything else, let me know. Thanks for joining me, and I'll see you next time.